Welcome. We're looking at task 5.3, and they have some definitions that they're reviewing first. The first thing is an altitude. This represents an altitude because it's a right angle. The other one is a median. This is a median because it splits the segment into two equal parts. This is a angle bisector because it splits this angle into two congruent angles. And then finally, this is a perpendicular bisector because not only is it perpendicular, that's 90 degrees, it also splits the side into two congruent parts. So those are four types of segments that you can draw here on this triangle. And so here you see this is the example of the equilateral, and they folded it, and this blue line, they're trying to decide which of these four things: altitude, median, angle bisector, or perpendicular bisector. Okay, and to claim that it is a median, then you would need to show that this segment and this segment are congruent. So AD is congruent to BD. Okay. Now, if we wanted to show that it's an angle bisector, we would have to show that this angle and this angle, so angle, bring this down, ACD would have to be congruent to angle BCD. So that would mean that, let's make this a little bit bigger so we can see it. Okay, so if it's an angle bisector, ACD is going to have to be congruent to BCD. Okay, and that would be an angle bisector. Yeah, take that back out. Oh, I don't want to go all the way. So it's ACD, BCD, ACD congruent to BCD. And then the other one is an altitude. In order for it to be an altitude, you would have to demonstrate a right angle. So that would be ADC. Angle ADC is a right angle. And then finally, if you were trying to show a perpendicular bisector, not only are you showing it's a right angle, but you're also showing that it splits that base into two congruent segments. So in this case, you are going to use this one, and you're also need to show this one. Okay, both of those for the perpendicular bisector.